Thank you for having me here. I really want to thank DSPA for this invitation. This is, to me, is going to be my first public talk about OutSystems AI and the amazing project that we're undergoing in really bringing software development to the next level by applying artificial intelligence to accelerate, to assist, and ultimately to automate the process of developing software and applications. And I forgot the clicker. All right, it's going to be better. All right, so looking back through history, if we go way back, tools really were a key part in humanity's journey and progress throughout time. You know, from rocks and spears and fire and the wheel and chariots and the steam engine and computers. These tools have enabled humanity to go beyond what they would be possible to do on their own. It enables them, it empowers them. And recently, software became the ultimate tool, right? Because this is a tool that is very, very plastic. You can make with it whatever you want, and you can evolve it very quickly. You can experiment with things, you can fail, you can iterate, and you can improve software itself by building better tools. And so this has driven amazing achievements. So together with hardware, of course, but software is what is underlying the internet, is what's underlying the mobile revolution, is what's underlying the cryptocurrency revolution. It's what our current society is built on. And if you look at the top companies worldwide, these are all now software companies. And this is because this is the ultimate tool that we found. And as I've said, the power is that the tools themselves are software. And so these are continuously evolving as well. So what you see here is OutSystems software development platform, which essentially accelerates, by our measures, about 10 times compared to other software development stacks, the speed that you get to your applications or your software, be it a mobile app or your internal HR management tool. And it has this visual language for programming, and it just raises the level of abstractions how you're doing things. But still, we're still limited. So we have better tools. Tools have been evolving, but the needs and the things we need to do as a society also keep increasing. So you have better tools, but the needs are increasing. And we are limited as humans in what we can do and what we can fill in our heads, right? We're very capable, but there comes a point where it's too complex. And you guys all know, if anyone here has worked in a software project, they tend to take a long time, there are bugs, things don't go as planned, you have these amazing specifications and documents, but it doesn't match reality. And so there's kind of a limit. If you look at all of the possible programs we might want to develop one day to support our business ideas, to support new ventures, there's only so much we can do, even with better tools. And so a good example of these kinds of things that manually humans cannot do a very good job at, even with amazing tools, is, for example, image recognition or language translation, or a lot of the things that deep learning now has made available to us. And this is because we are just not able to code all of the different corner cases that we need to code up, right? If we wanted to express how do you take an image and recognize if it's a cat or something else, you could kind of try to create abstractions and different modules to do that. And that's what we did before, and that's what classical AI used to do before, but it only goes so far. So deep learning brought a data-driven approach where we don't exactly know how to do it, but we have a lot of data, and we have a method to extract patterns from that data using a lot of computing power. And so essentially, this is what deep learning does. And deep learning was very successful and because it was able to tackle these problems, kind of expanded our possibilities. But essentially, deep learning, with all its power and with the amazing things that we've done with it, it's a pretty simple concept. So it's essentially a method for you to take a set of data in a certain input space, so in a manifold, as you will, with many dimensions. You have all of these points. Could be an image, could be a text, could be a document, could be fraud transactions. And you have all of these different layers in the deep learning network. Each layer is essentially doing a transformation of the data until it gets to your target desired space. So for example, let's take the fraud detection example. So you have financial transactions in one space, and this is essentially you have the amount, you have who did it, what time of day. All of these are dimensions in the data. So you can imagine the data to be like this crumpled piece of paper, right? And on the other hand, you want to map this, you want to convert those transactions into, is this fraud or not? Or what kind of fraud this is. So each deep learning layer is going to fold a little bit of this. So this layer is going to fold it a bit like this, the other layer like that, and you get a clean, flat piece of paper. So with enough data and with enough layers, you can pretty much build almost anything as long as you can map your problem to the data and as long as you have enough layers and as long as you have enough compute power. And this is great. And the magic behind this is that deep learning leverages optimization as a way to find within, if you look back at that diagram of the program space, you have a huge amount, an infinite even amount of different programs you can do to detect fraud. And you have all of this data. And you have an algorithm that goes and searches efficiently over that program space to find something that is able to unfold that piece of paper, right? And this is done automatically. And the program is essentially the weights of the model. And going forward and picking up on what Margarida was talking about with AutoML, we are now able to even automate the process of designing how many layers we're going to have, what are the hyperparameters, etc. So you can even automate the structure of the model you're going to use. And so this is super powerful. It just takes work to a next level. Right? And so this is what it looks like. If you map what deep learning brought to the program space over what we've seen before, it allows you to expand what you can do, allows you to search automatically over that program space. And so taking a concept that was coined by Andrej Karpathy from Tesla, you have what we're calling software 1.0 and software 2.0. Software 1.0 is the typical software that humans write, they code in a programming language, and then you have these learned systems from data that are able to reach an immense complexity we're not even able to understand, but they're also limited in scope. But as long as you have enough data, you can do it, right? But you don't have enough data for everything. And humans, for example, if you compare when they learn, for example, a human to learn that if they put themselves in front of a car, they're going to die or be run over, you don't need to experiment with all the different possibilities of putting yourself in front of a car and getting hit by a car. You die immediately. That wouldn't be a good evolutionary strategy. So we are able to reason, abstract, and be more data efficient in developing our strategies to deal with the world. And deep learning is more constrained with the data it has. And so these two kinds of software are characterized in the following way. So you have software 1.0, it requires domain expertise. 1.0, it's typically an engineering-driven approach. You decompose the problem, you break the problem down into smaller chunks, you compose everything, you test it, it works or doesn't work, performance is bad, you tune it, and you kind of iterate manually on it. On deep learning, you don't really require a lot of domain expertise in developing the model itself. As long as you have the data, you need to create the skeleton that maps the data to the problem you're using, and then even using AutoML, you can just automate the whole process. And this is really powerful. And if you're looking at these two, these are complementary. And even deep learning systems nowadays, they leverage software 1.0. So for example, if you look at, Google Translate, there are some very sophisticated algorithms there, but then you have the website, you have the user interface, you have all of these mechanisms. These are software 1.0 supporting a 2.0 system. And these two systems also underlie different kinds of AI. Deep learning is more of a geometric AI in the sense that it does data transformations in a multi-dimension space. It's very good for pattern recognition problems. It's very good for capturing intuition, things we're not even sure how we capture, but it learns. And software 1.0 is more associated with the classical AI, with planning and game theory and things like that, right? But even though we have these two, we still are not able to do everything we want and we dream. And especially, it's still limited to people that are have a very specific skill set. So how do we expand the space of what we can do, and how do we enable people with less skills to really take control of this powerful tool that is software? So what if software was able to follow this kind of approach where it's automatically generated, tested, and evolved? And to this we call software 3.0, is taking an approach like deep learning, but applying it to the construction of 1.0 software, so regular software with code. And so this is a world where we see AI assembling and creating software components. These components can be just classical coded components, could be deep learning components for the things that they do best. If you need abstraction, if you need reasoning, you would use regular programming. If you need pattern recognition and intuition, you would use deep learning. And so this underlies the vision for what we call OutSystems AI. So OutSystems has been always focused in accelerating and enabling people to write their own software easier. And we're looking at the next level and how we can go from low code, which is what we call the kind of tool we use, to smart code, to a world where you have artificial intelligence either accelerating you, suggesting what you should do next, or completely automating some parts of the process, and down the line, the complete process itself. And so we have a very ambitious ultimate goal. And at first, when I heard about this ambition of OutSystems before I joined, I was like, whoa, this is really big. I can't even put it inside my head what you're trying to do here. This is almost reaching a singularity, right? But this is why I took the challenge, because although it's a very early time, we know there's a path to get there. And so our ultimate goal is to make software development a universal, so accessible to everyone, and a purely creative endeavor. So it's not going to be an engineering endeavor where you need to map from your problem space to an algorithm and a recipe and components and all of that. No, it's more of a communicative state where you say what you want, you express your needs, you set goals, you set requirements, and this is kind of results in software that is indestructible, which means that it's very high quality, very hard to make it bad, and that is able to self-evolve as the needs evolve as well. And so why is OutSystems doing this? So first, although we have a great tool to build software, it's still too hard. You still need a specific skill set. It's still very easy to have bugs. You still need to be able to do this magical thinking of, I want to make this car move from point A to point B, so now I need to write a recipe, move wheel X degrees to the right, and then accelerate X meters per second, like a recipe. You need to think like a robot. And this is not a natural thing for humans to do. And associated with this, there is a skills gap in engineering and software development, and even in data science and AI. And this is increasing. So the needs that companies have for people who are able to manipulate these systems, create new systems, and evolve them is growing faster than the amount of people that are at least coming out of university and getting graduated with this kind of skill set. So it's going to be an increasing problem, and we need to fix it. And more importantly, although OutSystems is a leader in its market, we understand the importance of being 10 steps ahead and disrupting ourselves from the inside. So we decided to go through this path because we understand that this is an important vector that's going to happen in the world. And our product is not going to stay relevant forever. So we really want to bring in a world controlled by us, or at least that we are able to influence, that is going to make our current product obsolete. And that's a big driver for our decision to invest here. So how will we get there? This is a very ambitious plan. And so we have a very ambitious master plan going up to 2040. When we started to think about what we were going to do, we realized that this was too big. So let's try to think back from our end goal to different stages and what we need at different stages to get there, right? And so we have first the foundation stage where we need to set up the infrastructure, get the data going, have the right skill set, have the right people, have the right technology, start experimenting, start getting feedback, And this would be akin to someone who wants to launch a rocket. They need to get their, the materials to build a rocket, they need to do some tests, they need to do test flights, etc. Then you have exploration, where we're starting to ship features to our customers and gathering feedback. Transformation, where AI is already changing the way that software is written and plays a big part in our sales cycle as well. This will be the part where it will actually differentiate us and change the way people use our product. And then going forward, there's a phase of disruption where people, citizen developers, people that do not have this kind of specialized skill are aided by an artificial architect, an artificial expert that's going to guide their way to understand how to build these complex systems, and it's going to automate a lot of things. And at the end of the line, you have a world that we see where people build software, even the concept of software is going to be different, continuously every day, and it's something that it continuously evolves and responds to your needs. And so we're going to drive this by a lot of research, and we're doing research in a lot of different areas, from development itself, from quality assurance, architecture, product design, customer satisfaction. We are looking at every step of the software development lifecycle, and we're looking how we can use AI to make it much faster, more automated, and support and empower software developers, business people, our customers to really get their goals to where they want. And so we now are working on three main pillars. The first one, which is the one that's going to have more of a short-term impact, is assistance. And this is for providing guidance at each step of the way when someone is programming a function or is designing their data model or is designing their UI. We're going to tell them, hey, you probably want to do this next, or these are the two options you probably want to use, and these are the configurations you want to use. So instead of people having 50 different options for their next step, they're going to have 1, 2, or 3. And this is going to accelerate pro users, but it's also going to make new users, novices, much more open to using the product. And we'll be showing some very interesting things very soon, by the end of this month. Very exciting, where we're going to start bringing these improvements to the product. The second one is analysis. And this is more of a higher level architectural perspective from the system. And we're going to try to focus how can we use AI to understand the full architecture of a system, the different components, how do they relate, and how can we say, this is a better way to structure your system. This is the component that is reusable, and you probably should use this for other people and for other purposes. And then the final one, which we're already working on with a research partnership with Carnegie Mellon and Instituto Superior Técnico, which is on synthesis. And this is actually how do you have AI automatically, based on a goal you give them, program a function automatically, test an application automatically, or design a UI automatically. And there is already some work, state-of-the-art work in these areas, and we're investing to really bring this forward and push this ahead more than it's possible. We use all kinds of data for this, and that's a kind of an exciting part of our work, because we have source code data, we have error logs, we have performance data, we have customer satisfaction data, and we can use all of this to teach an AI to understand what's a good app, what's a bad app, what's a good customer experience, what's a bad customer experience. What should you do so that your software is faster or better? And we can use this to then give suggestions and have a system that is able to learn how to build great apps, right? And we have an advantage, I think, even across the industry and the research community on this area, is that our data is at a higher level. We're not dealing with text code. We're dealing with highly structured code that is a graph that has a higher level of abstraction, and this is going to help us learn more. And this is why we believe we are at a unique position to really change an area that hasn't seen a lot of investment. There's a lot of challenges here, and I think I'm just going to finish up. Compared to, for example, an area like natural language processing, it's first very early, and I've been speaking with some of the leading researchers in the area worldwide, and the idea is that there are less than 50 people in the world that has been working in this area of AI applied to software development. And we will be one of the key research groups moving this area forward, and really betting a lot on that. And it's much harder than NLP because the data is sparser. People just make up names when they're naming their functions or variables. There's a lot of different structure. There are dependencies that are really long. I mean, you create a module here, use it there, It's not like language where sentences kind of have a locality about them. And on top of that, there is no explicit labels for things. We don't have things saying this function does this, and this is a good function. This is a good way to write your program. This is a bad way. We have to infer it from performance data and customer satisfaction. We are doing a big push to take this research to our product and to our customers, and we're working very closely with product teams, engineering teams, and you should see some very interesting news by the end of the month. I can't reveal it right now, unfortunately, but we'll have some very interesting AI-powered features in our product that is going to accelerate people and guide them when they're developing their own software very soon. Thank you so much for having me.